Hello, my name is Daniel Rustan, and I am a student in the Healthcare Informatics program here at Bellevue College, and I'm doing my capstone presentation on a new technology called Smart on Fire. A little bit about my background. I have 8 years of experience in healthcare IT. I'm currently a project manager for a healthcare application developer, and Smart on Fire is a development standard that could truly just change the way that we do business. And so I wanted to take a look at this new technology and see whether it's able to live up to all the claims that are being made around it. So for this presentation, we'll start off with an explanation of what Smart on Fire is. We'll discuss a lot of the hopes and the promise and some of the hype that surrounds this new piece of technology. And then we'll take a look at some of the experiences of people who have actually built applications using this standard and really evaluate their experiences to see if Smart on Fire can live up to its promise. So, what is Smart on Fire? Smart on Fire is a standard that provides a framework or a set of rules for people to follow when they're developing healthcare applications. The idea behind it is to simplify. This standard, interestingly, is made up of other standards that are widely used on the web. And the hope is that by using these common technologies that are used all over the place, we would make healthcare applications that can be used in a wide variety of places. So to dig a little bit deeper, let's take a look at the individual pieces of Smart on Fire. Smart on Fire is actually made up of two standards. First, we have SMART, which stands for Substitutable Medical Applications and Reusable Technologies. The idea behind SMART was to create a way for application developers to develop an application once and be able to deploy it across multiple systems. And it's based off of open standards, which are standards that are widely used and can be used without paying for a license. OpenAuth or OAuth 2.0 and OpenID handle authentication and authorization, much like those login with Facebook or login with Google buttons you see on the internet. They provide a way for you to log into an application by using your credentials from another application. And then HTML5 is designated for the user interface, and HTML is what is used to build the front end of every web page on the internet. Now, on the other hand, we have FHIR. FHIR stands for Fast Health Interoperability Resources, and again, it uses a web technology. In this case, it uses HTTP for data transfer, just like every internet or just like every site on the internet. And then for data itself, for the data formats, it uses healthcare terminologies and code sets, and it uses the ones that are required by Meaningful Use 2. The reason it does that is because Meaningful Use 2 says that any EHR or health system that wants to be certified has to use these terminologies. So any healthcare application that develops to the FHIR standard and therefore uses these terminologies will be able to exchange data with any certified EHR or healthcare system. So the reason there's so much excitement around this is because the current implementation methods are challenging and expensive. I've worked on integrations that took 6 months or more. Smart on Fire promises the ability to add and remove applications from an EHR just like we do on our cell phones. It could create a healthcare application marketplace, and that would increase the speed with which applications are built and allow medical practice to keep up with medical science. It also allows developers to reuse code instead of building custom applications for every platform. Right now, if you want to integrate with Allscripts, you have to integrate integrate the way that Allscripts wants you to integrate. And if you want to integrate with Epic, you have to do it their way, which is completely different. And that means basically developing custom applications for every system. So, the way I set about looking into this was by looking at the people who have actually used this standard. Early adopters are just now starting to publish papers about developing their applications within the last 18, 24 months. And so I'm going to look into these to really see if Fire can live up to its promise, again, with regard to implementation, usability, and semantic interoperability. So when I looked at this, what did I find? Well, as far as implementation goes, most developers really thought that Smart on Fire made implementation easier, but they also had criticisms. OAuth and OpenID are easy to use in place of custom authentication frameworks, and they're more secure as well. The use of standards allows developers to make their offerings widely available across multiple platforms. And one organization, Duke, was able to realize the promise of Smart on Fire, and they had an implementation that took roughly about 5 minutes and the click of one button. That's revolutionary. But it's not perfect. One application had to customize the authorization framework. An organization that implemented their product had different security requirements, and so they had to make the customizations to fit those needs. And unfortunately, that would prevent substitutability. As far as usability goes, they mentioned challenges with the authorization framework, but it not only provides a lot of positives for implementation, but also provides positives for usability. The auth framework eliminates login steps, so when a clinician launches Smart on Fire, they don't need to enter credentials. In addition, Fire is able to improve usability by eliminating the need for a lot of data entry. It's able to use the Fire resources to pull data from the EHR directly and then use that in the application. And this gets especially useful for data that's obscured or hard to get to in the EHR, and as well as data that needs to be pulled from different sources. A Smart on Fire application could pull genetic results from a lab reporting system, combine that with data it pulls from an EHR, and combine them in an application that can do great things for a provider. Now, semantic interoperability requires not just the exchange of data, but a shared understanding of context as well. For example, it's not hard to pass 144 over 90 from one computer system to another, and that would be an example of interoperability. But for a system to understand that 144 over 90 is a high blood pressure measurement, and then to be able to take that in and provide guidance to a provider on how to manage that high blood pressure, that is semantic interoperability. So Fire's use of meaningful use terminologies allows for semantic interoperability, but it doesn't guarantee it. In order for semantic interoperability to be achieved, there has to be accurate mappings of Fire resources to the data elements in a healthcare system. And right now, mappings could be done differently in different systems, which would not solve any of the problems that Smart on Fire hopes to solve. One group that developed an application, they found that mapping the data elements required for their application was fine, but if they had to map all of the data for all of the Fire resources, that would be a barrier to adoption for them. And the final con for semantic interoperability is just that healthcare data is so diverse that Fire just does not right now contain all the resources for some of the data that's out there. So what conclusions can we draw from all of this? Well, each development group had a specific goal in mind when they were developing their applications. There was a research facility that was sitting on a ton of research data, but they lacked semantic interoperability, and that prevented them from using that data in cross study ways. Smart on Fire helped them, but they were concerned about the extensiveness and the accuracy of mappings. Duke set out to build applications that they could share with their partners outside their walls. They achieved that, but they had questions about the authentication framework and about the extensiveness of the mappings. There were third-party developers that their goal was just to make their product widely available. Now they're available in Epic and Cerner and Allscripts, but one of those had to do customizations for one of their customers. So all in all, I think that Smart on Fire has the power to revolutionize the way that healthcare applications are built and implemented. It offers huge improvements over current capabilities, and it really could usher in a new level of interoperability. So it has the power, but it will depend on how it's implemented across the industry. As Spider-Man likes to say, with great power comes great responsibility. And the power of Smart on Fire must be managed responsibly in order for it to be successful. I interviewed a developer who has experience in developing Smart on Fire applications, and we were discussing the possibility of the healthcare application marketplace. And he pointed out that those applications are controlled by a central authority. If you want to play an Android sandbox or the iOS sandbox, you have to play by their rules. So for Smart on Fire to work in healthcare, there needs to be a central authority that can establish rules for anybody who wants to play in the Smart on Fire sandbox. Luckily, there is such a group right now. They're called the Argonauts, and they're made up of competing vendors, standards organizations, regulators, and even healthcare organizations. And if they can get everyone to come to a consensus on a broad implementation of the standard, then I think we can really begin to realize huge improvements in healthcare applications, especially in the areas of implementation, usability, and semantic interoperability. Thank you for your time.